All right, so you should have just finished watching the distributive property video just to reacquaint you with what distributive property is. And so now what you need in front of you is your notebook or lined paper where you did some vocab terms last week. We're going to add to that. And then also your book to page 375. So as soon as you have those ready, we'll get started. I'll meet you back here. Okay, so our seventh vocab term that we're going to look at is distributive property. The six that we did last week were algebraic expression, term, variable, constant, coefficient, and like terms. So distributive property is now lesson 4. And so this is actually something last year in 6th grade that you did a little bit with. And so hopefully as we start to go through this today, you start to recognize and understand and remember where this came from last year. So distributive property, you're going to write down, is where you multiply each term inside the parentheses by the number outside the parentheses. So for example, I used one with just all variables. So we would take A on the outside of the parentheses and multiply it by everything on the inside of the parentheses, which is B plus C. Example number 2, I use just numbers. And so the 5 on the outside of the parentheses, we would multiply it by everything inside the parentheses, which is 4 minus 2. And the last one, I used a variable. So the negative 3 on the outside of the parentheses would get multiplied by everything inside, x plus 9. So make sure you have that definition written down and those examples written down. And so now what we're going to do is we're going to look at an example just really quick. And so you can add this wherever you have room in your notebook. And again, I'll meet you back here as soon as you're all set. Okay, here we go. So this is the example I want to just talk about with you for a few minutes. Let's say, for example, you're given this situation. 4 friends go to Michigan Adventure. They each pay $20 for tickets, which is a pretty good deal, and $5 each for pop. How much money do they spend all together? And so I put idea number 1 and idea number 2. So I guess what I want to talk about first is just think about like how you would figure this out in your head. If there's 4 friends going and each one is going to pay $20 for tickets and each one is going to pay $5 for pop, in your head, I'm sure you're thinking, well, I'm going to do this. I'm going to take 4 and I'm going to multiply it by the $20, right? Which means you and your friends are spending $80 on tickets. And then you're thinking, okay, well, again, there's 4 of us. Each pop is 5. So that means we're spending $20 just on pop. Well, add those together, right? 80 plus 20. You're going to spend a total of $100. Again, that's a pretty good deal. So, yep, that's typically, I think, how you would process that problem. Now, idea 2. How does that look a little differently? What's a different way I could write this? Well, when I look at idea number 1, I notice 4 is in common with both the tickets and the pop. And so if I were to set this up as a distributive property problem, I'm going to put that 4 on the outside of the parentheses, knowing I have to take and multiply it by everything inside the parentheses. Well, that's the $20 ticket, and that's the $5 pop right there. And so think about that. 20 plus 5 on the inside of the parentheses, that's $25. Times 4 on the outside of the parentheses, that's $100. And so absolutely you're going to get the same answer. If you think about when I talk about distributive property, I'm thinking about this. I'm thinking about multiplying everything on the inside, right? So 4 times 20. Over here in idea number 1, that's what you see. 4 times 20. Plus, again, I multiply by everything on the inside there. 4 times 5. Over here, that's exactly what you see. 4 times 5. 80 plus 20, $100. 4 times everything inside those parentheses is going to give you your answer, your value. And so they're set up 2 different ways. The thought process might be 2 different ways, but in math, there's lots of different ways you can solve problems. In this case, right, you're looking at an example of distributive property. Okay, So at this point, we're going to transition into book page 375, where it's going to give us a couple different examples with this same thought here. So we're going to head here next, and we're going to look at this real world link. So let's talk about the real world link example with school supplies. It says that Jordan is going to buy 3 notebooks that cost $5 each. He's also going to buy 3 packages of pens for $6 each. Number 1, write an expression that shows the cost of 3 notebooks added to the cost of 3 packages of pens. So look at how they've started to set up the expression for you. What are you going to multiply by $5 and what are you going to multiply by $6? Well, the notebooks are 5 each. You're buying 3 of them. 3 times $5. Again, the package of pens are $6 and you're buying 3 of them. And so 3 times $5 plus 3 times $6. So this is one way to set the expression up. Number 2, write an expression that shows 3 times the cost of 1 notebook and 1 package of pens. So that's saying, all right, while we know 3 is in common with the notebooks and the pens, and so that 3 is going to come outside the parentheses here. And we know 1 notebook is $5, and 1 package of pens is $6. So now in number 2, we're setting it up to look like a distributive property type of problem. You're going to multiply 3 by everything inside the parentheses, which is $5 plus $6. Well, number 3 says evaluate both expressions, and what do you notice? Okay, well, if we go back up to number 1, 3 times 5, you're going to spend $15 on notebooks. Plus 3 times 6, you're going to spend $18 on the packages of pens. And so if we add those two together, we have $33 that we're spending on those supplies. Well, can we get the same answer in number 2? So think of it as distributive, right? So if I take that 3 and multiply it by everything on the inside of the parentheses, that means I'm doing 3 times $5. I'm doing 3 times $6, right? So 3 times 5, 3 times 6, and then I want to add those together. So that means I'm getting 15 plus 18, also for a total of $33. I get the exact same amount that I did in number 1. All I did differently in number 2 was just show how to complete that problem as a distributive property problem and distribute the 3 to everything inside. So what do you notice? Well, you notice that both expressions are the same value. Okay, let's look at number 4. Suppose Jordan buys 5 notebooks that cost $3 each and 5 packages of pens that cost $1 each. Circle the expressions that represent Jordan's purchases. $3 each for each notebook, $1 each for each package of pen. And so based on what we just did in number 1 and number 2, this first example right here is one way that you could set that up. We did that exact same thing back in number 1. Then if you keep looking, the other way we set it up was like in number 2, where we took and understood that 5 was in common with both the notebooks and the pens. You're buying 5 of each. And so we take and put that on the outside of the parentheses because we can take and multiply by 3 and by 1, everything inside the parentheses. We don't want to pick the second one here. If you notice, everything has a multiplication symbol in between. We don't want to multiply everything, right? We only want to multiply the given sets of quantities. So 5 notebooks, $3 each. 5 packages of pens, $1 each, and then add those together. Okay, number 5. Suppose Jordan buys 2 rulers that cost $1 each and 2 folders that cost $1.50 each. Once again, we want to circle the expressions that represent his purchases. So I'd be circling the third one, and I'd be circling the second one. What's wrong with the first one? Take a look. So hopefully you're noticing there's adding signs in between. Well, we don't want to do that. That's not going to give us the quantity or the amount that we need for what Jordan is buying. So we're looking at distributive property. Now we're going to do just a couple more problems today to just, again, refresh your memory on how it works and what you learned a little bit last year. So we're going to take and scroll down a little bit. And we're going to look at the got it on the bottom of page 376. So you are definitely going to start to see the integers come in. And so when you do chapter 3 with your integers, you start to see it the rest of the year. It goes in every chapter now that we talk about and go over all the way through June. They're really going to start to come out more in this chapter, starting with distributive property. And so those integer rules of add, subtract, multiply, divide, you have to really make sure you're getting comfortable with those. So let's try a couple here. Let's look at letter A. It says 5 times -9 plus 11. So this 5, what I can do with it is distribute it to everything inside the parentheses and find my answer. But the other way I can look at this right now is there's no variables at all in either A, B, or C. None of these examples show a variable. And so since it doesn't, I can actually use order of operations. So I'm going to show both, okay? So letter A, let's talk about this one first. So let's do order of operations and see what we get. We're going to do inside the parentheses first, right? So -9 plus 11, that would be 2. So remember with your integer rules, when you have opposite signs, one negative, one positive, you subtract. And you do take the sign of the larger absolute value. So this 11 is larger and it's positive. My answer is positive 2 here. Well then now, once I've done the inside of the parentheses, I'm going to multiply. So 5 times 2, 10. And so that's just using order of operations to solve that expression. Now let's say in number 2, I use distributive property. Okay, so I'm going to rewrite this here. And I'm going to show taking that 5 and distributing it to everything inside the parentheses. So you're going to start to see I'm drawing these arrows. And I'm drawing them so that you see I want to make sure that that 5 on the outside gets multiplied by everything inside. So I don't want to forget. I want to make sure I do 5 times -9. So I draw that arrow. I want to make sure I do 5 times 11. So I draw that arrow. So it sometimes looks like a rainbow. As you do that, it forces you to not forget anything inside the parentheses when you do that. So what does that look like? Well, if I do 5 times -9, right? And then I'm going to say plus 5 times 11. So I'm distributing the 5 times the -9 here. Now I got to think about multiplication integer rules. 5 times -9 is -45. One negative when you multiply is negative. Plus 5 times 11, 55. So at this point, I still need to finish. -45 plus 55, you have opposite signs again. And when you have opposite signs, you subtract. Sign of the larger value. This is also going to give you an answer of 10. So in letter A, when you evaluate that expression, you have an answer of 10. You can do an order of operations or you can do distributive property. Now, honestly, if it was me and I'm looking at letter B and I'm looking at letter C, I'm going to do order of operations because I know how to do order of operations and that's familiar to me. And it also helps me get the problem done quicker. On the other side of that, right, we are learning distributive property. And so you can absolutely do B and C with distributive property. I'll stick with order of operations on this one. So letter B, let's do 10 minus 5 and get 5. And then multiply it by 7. 7 times 5, 35. Okay, letter B, 35 when you evaluate it. If you were to do distributive, you're going to get the exact same answer. Letter C, 12 minus 8 in parentheses times 9. They just flip the 9 over to the right side of the parentheses, and that's okay. Again, if we're going to do order of operations, we're going to do 12 minus 8 and get 4. And then multiply it by 9. 4 times 9, 36. Once again, if I were to do distributive property and distribute that 9, I would also get an answer of 36. Well, you know, all of your problems with distributive aren't going to be that easy. You are going to start to see where you have variables. So we're actually going to use the variables tomorrow. I'll show more examples with those tomorrow. What I'm going to have you end with today is just ones with the numbers. Whoops, and I have an answer key there. So give me a second. Let me go back and clear that out, and we're going to work through a couple of those together. So hold tight. Okay, let's try this again. So independent practice. This is page 379. And so like I said, we're just going to focus on the ones with no variables, like we just did in the got it's. And tomorrow we'll start bringing the variables in and doing those. Okay, so I'm going to do a couple and then I'm going to have you try a couple. So I'm going to look at the ones with the negatives. So number 2, you've got 6 plus 4 in parentheses times negative 12. I am totally okay if you want to do order of operations here, knowing you don't have any variables. Really, you know, that might be a good idea so you can be comfortable with using your integer rules. So if I do 6 plus 4 and get 10, and I multiply that by a negative 12, well, think about 10 times 12. Well, that's going to give you 120. Now think about your integer rule there. You have one positive and one negative. And so when you multiply with one negative, your answer is negative. Negative 120. Okay, I'm going to do one more because number 6 is kind of tricky here. So number 6 says, in parentheses, 5 minus 7, and then you're going to multiply that by negative 3. So you're looking at inside the parentheses here, taking a larger number away from a smaller. You're trying to take 7 away from 5. Well, you know that's not going to give you a positive answer, right? So think about in these terms here, leave, change, opposite. So I'm going to rewrite this. Leave the 5, change to addition, opposite. That's a negative 7 right there. And you want to then be able to take and multiply by negative 3. So I rewrote this underneath using the leave, change, opposite. So you see that that's a negative. 7, when you take 7 away from 5, you're going to get a negative value. 5 plus negative 7, well, that's negative 2, right? Opposite signs subtract, sign of the larger value, negative 2, times negative 3. Negative 2 times negative 3, positive 6. Two negatives multiplied together, positive value. You try 1, 3, 4, and 5. You finish these 4 out right here. Try them. And then pause the video. Obviously, when you do that, come back and check your answers when you're all set. Okay, number 1. You should have gotten 33. 5 plus 6 is 11 times 3, 33. Number 3, inside the parentheses, 9 minus 4 is 5. 5 times negative 6, negative 30. Number 4, in the parentheses, negative 6 plus positive 4 is a negative 2. Negative 2 times 5 is a negative 10. And number 6, we did together. Number 5, 8 minus 7 is 1. 1 times 4 is 4. So if you find that you're struggling with your integer rules, my suggestion would be to go into that quiz like you did last week and practice those a little bit more. Go back in and do the skill and drill with add, subtract, multiply, divide. So you're constantly practicing those rules. We're going to stop, like I said, here today. And tomorrow we'll start doing some examples with the variables. So now where you're headed with the last part of the hour, if you still have some time, is either finishing up some buzz math or going into Alex, either one of those to end the hour. So we'll see you back here tomorrow.